Good afternoon, dear students. Yes. So today we are going to see the next topic. Okay, so we are going to solve MCQs. Okay, on the next topic. So our next topic is D and F block elements. Okay, so we are going to discuss about D and F block elements. So as you have already seen in your first and second year, right? You have studied about the elements. Okay, you have seen the periodic table. So how the periodic table is divided. So the periodic table is divided into four blocks. Okay, S block, P block, D and F block. Okay, so we are going to see about D and F block. So D block are what? D block consists of your transition elements, and F block they consist of what? They consist of lanthanides and actinides compounds, right? So we are going to discuss few questions on this particular topic. So let us see. So here basically the questions are theoretical type only. Okay, so D and F block elements. So it is theory based questions. Okay, so let us see. So this is our first question. So the first question is the transition element have a general electronic configuration of. So what is the general electronic configuration of the transition element? Transition elements are your D block elements. Okay, so they are termed as D block elements. So can you tell me what is the general electronic configuration? Yes, so go through the four options A, B, C, and D, and you can give the answers. Okay, you can use the chat box for answering. So you can give the answer there. So what is the correct answer? What is the general electronic configuration? General electronic configuration means what? The last electron where it is filled. Okay, the filling of electrons, last electron in which subshell it takes place. So okay, I've got answer. Pavitra and Shivganga has replied as C. Okay, what about others? What about others? What is the correct answer? Yes. Okay, so there are, okay, so we have your four options. So the in D block elements, okay, in your transition elements, you can see that the outermost electronic configuration is N minus 1 D, N minus 1 D, okay, 1 to 10. That is electrons accommodate from 1 to 10 and NS 1 to 2. So this is the general electronic configuration of the transition elements. Okay, so option number C is the correct answer. Very good. Okay. So please answer. Others also be active. Okay. Next question. Which one of the following characteristics of the transition metals is associated with their catalytic activity? So which of the following characteristics of the transition metals is associated with their catalytic activity? A. Variable oxidation state. B. High enthalpy of atomization. C. Paramagnetic behavior. And D. Color of hydrated ions. Yes, what is the catalytic property with what it is associated? So there are few characteristics. Okay, so there are some general characteristics shown by the transition metal. So the catalytic activity is one of the like most of the transition metals, they act as a catalytic. They have that property of showing catalytic activity. Catalytic activity means what? They can be used as a catalyst. Okay, so that they help to speed up the reaction. So with which other property it is associated? Okay, Pavitra, Shivganga, Aishu, Suma, and Basavaraj have answered it as A. Yes. Okay. So A is the correct answer. Very good. So you have seen, okay, in your theory, okay, you might have gone to the synopsis also. So there you can see that the transition metals, okay, what is the general electronic configuration? N minus 1D, 1 to 10, NS, 1 to 2. Okay, so they have the ability. So these transition metals, they have the ability to utilize these inner orbitals. Okay, so those they have the property of showing variable oxidation state. Okay, So it has a unique property to show different oxidation. Variable means different oxidation state. Okay, and it will what it will do, it will associate with the different reactants in different forms. So it is option number A. So A is the correct answer. So let us go for the next one. Okay, so the oxidation state of chromium in K2Cr2O7 is, what is the oxidation state of Cr in K2Cr2O7, that is chromium. What is the oxidation state of chromium? Can anyone tell me? A plus 5, B plus 3, C plus 6, and D plus 7. Okay. Okay, I've got few answers. Aishu has answered it as C. Suma has answered it as B. Sita has also answered it as B. Okay. Any more answers you want to give? Yes, others, anybody else? Or should I tell you the answer? Okay, one more answer I got. Shiv Ganga and Pavitra has answered as B. Okay. Anybody else? K2Cr2O7 is what? Potassium dichromate. Okay, so this we have studied in what? You might have studied in the important compounds of transition elements. Okay, so two important compounds has been to study, that is KMnO4 and K2Cr2O7, right? So here, so first we'll determine what is the oxidation state of chromium. So chromium we don't know. So potassium, what is the general the so we need to know some of the what is that common oxidation state. Okay, you know, so potassium is what? Potassium is a alkali metal. Okay, potassium is a alkali metal, and it comes under what? Potassium is an alkali metal, and the outermost electron, okay, so it can give +1, so +1 electrons, so 1 electron it can give, so it will be in its +1 state. So common oxidation state shown by potassium is +1. Then that of oxygen is what? Oxygen commonly it is formed in -2. Okay, commonly, so potassium it will exhibit as +1 and oxygen will be -2. So let us, okay, Sita has answered as C. Okay, let us see. Now, okay, so there is how many? Okay, so how many potassiums? 2. So 2 into each potassium is 1. Okay, plus how many chromium? 2 chromium. We don't know. So let us keep it as 2x. Okay, plus how many oxygen? 7 oxygen. So let us write it as 7. Each oxygen is -2. Okay, then the whole, so there is no charge anything on this. So it will be equal to 0. Suppose CO3 -2. Okay, so that time we have to find the oxidation state of carbon, suppose. So how I'll write? X plus 3, each oxygen is -2, is equals to -2. So the charge is here -2. Okay, so like this we have to write the equation. So now here there was no charge, so we will write it as what? We will write it as 0. Now let us do this. 2 ones are 2 plus 2x. Okay, 7 twos are 14. So -14 equals to, plus minus will be minus. So it will be simple. Okay, algebraic equation. Then -14 and 2 will be 2x minus 12 equals to 0. Then 2x equals to 12. X is equals to 12 by 2. So it will be 6. It will be +6. So who all have answered it as C? Yes, Suma has answered as C. Sita has answered as C. Okay. Aishu has answered as C. Okay. So this is the correct answer. Good. Fine. So let us go for the next question. So it is option number C. Understood? So like this, you have to find the oxidation state. Okay. Oxidation state. So any. Now suppose K, okay, let us take here only one more. So I'll tell you to find the oxidation state of Mn in KMnO4. Okay, find for this. Find for this. Find the oxidation state of Mn in KMnO4. Okay. Sita has answered it as +7. Others? Seer? Okay, one more answer. Suma has also answered it as 7. Okay, so you have to specifically mention it is +7 or -7. Okay, so it is +7. So let us see. Potassium, okay, KMnO4. So potassium is 1 plus Mn, we have to find X plus 4 into -2 equal to 0. 1 plus X minus 8 equal to 0. X minus 7 equal to 0. X is equals to +7. So it is +7. Yes. Aishu Vasavraj, yes. Very good. Okay, so like this, you have to understand, okay, to find the oxidation state. So let us go for the next one. When MnO2 is fused with KOH, a colored compound is formed. The product and its color is. So this is what, when we are studying the compounds, okay, that is the transition compounds KMnO4. So while preparation of KMnO4, this is a first step. Okay, MnO2 is what? Pyrolusite. Okay, that is a ore, pyrolusite ore. So this is fused with what? It is fused with your KMnO4. Okay, so it is fused with your KMnO4, and what you get? Yes, what you get there? So these are the 4 options: A, K2MnO4, purple green; B, KMnO4, purple; C, Mn2O3, brown; and D, Mn3O4, black. Okay, Shiv Ganga has answered as B, Sita has answered as B, Aishu A, then Suma has answered it as B. Okay, so let us see what is the answer. So when MnO2, okay, so this was a reaction when we observe MnO2, when we fuse it with KOH. So this is the first step. Okay. In excess of air, we get K2MnO4. We get K2MnO4, which is purple green in color. Okay, it is purple green in color. So the Mn is oxidized to, what? Mn in alkaline medium is +6. Okay, so MnO2, it is oxidized to K2MnO4. Okay, in the presence of excess of oxygen in KOH medium. So we get purple green color. So this is the first step of preparation of KMnO4. So option number A is the correct one. Aishu has answered it right. Okay. So option number A. Very good. So let us go for the next one. The main reason for larger number of oxidation states exhibited by the actinoids than the corresponding lanthanoid is. The main reason for larger number of oxidation states exhibited by the actinoids than the corresponding lanthanoids is. Okay, Aishu has answered it as B. So the answer is yes. Sita has also answered it as B. It is B. Okay. So due to the energy, that is lesser energy difference between 5f and 60 orbitals than that of 4f and 5d orbitals. So when you see actinoids and lanthanoids, okay. So large number of oxidation state, variable oxidation states, they are shown more in actinoids as compared to that of lanthanides. The reason is that the energy difference, okay, the energy difference between the 4f and 6d orbitals is less, okay, as compared to that of 4f and 5d orbitals. So because of that reason, the actinoids, they show more oxidation states as compared to the your lanthanides. Okay. Next question. The complex ion, so this is a complex ion, okay, hexamino cobalt 3 is formed by sp3d2 hybridization. Hence, the ion should possess. So, what will be the geometry possessed by this complex? A. Octahedral geometry. B. Tetrahedral geometry. C. Square planar geometry. D. Tetragonal geometry. Okay, Aishu has answered it as A. What about others? Yes. Okay. Basavaraj and Sneha Shivganga have also answered it as A. So the complex ion, cobalt, okay, and NH3, 6 plus 3 ion will exhibit what geometry? Okay. So let us see. Okay. So it is what type of geometry? It is a octahedral geometry. It is a what type of geometry? It is a octahedral geometry. Okay. So the answer is, so when we see that, so this is according to what theory? It is a VSEPR theory. VS, okay, let me write it. So it is according to VSEPR theory. Okay, according to VSEPR theory. So if a molecule with 6 bond, okay, pairs. So here you can see that in this particular complex, the metal is here, the metal is bonded with the, you can see how many pairs of electrons are there? 6 pairs of electrons are there. Okay. So it should have what type of complex? It should have a octahedral complex. So option number A is the correct answer. Okay. Let us go for the next one. Which one of the following ionic species will impart color to an aqueous solution? So which ionic species will impart color to the aqueous solution? A. Titanium plus 4, B. Copper plus, C. Zinc plus 2, and D. Chromium plus 3. Yes. So which one of the following ionic species will impart color? So which system will show color? Yes, so transition metals, they have a unique property of showing colored complexes. Okay, this colored complexes is due to what? It is due to the presence of unpaired electron. Okay, so due to the behavior of paramagnetism, okay, paramagnetic behavior is shown by the metals which are having unpaired electrons. Okay, the electrons are not paired, so they are unpaired. So unpaired electrons will show that they will impart color to the system. Now, if you see titanium plus 4, copper plus, right, the this for what is that? Oxidation state for this, and you can see copper is 29. Okay, so it is 3D. So argon 18, 19, 20, 21, 22, 24, 25, 26, 27, 29. So it is 3D10, 4S1. Okay. Then copper plus. So here it will be copper plus means how much it will be? Copper plus 4S1. So it will be copper plus means it is 3d10 system. Okay, it will be 3d10. So all the electrons are paired. So it will be wrong. So copper plus is wrong. Then zinc is 30. So zinc system is also what? It is argon 18. Okay, 3d10 and 4s2. So here also after these two electrons are lost, it will be 3d10 system. So here also it is wrong. Then titanium, yes, right, do it for titanium and then for your this what? Chromium. Yes, just see how much you will get for titanium and chromium. Chromium is 24. Okay, so write it for chromium now. Chromium is 24, titanium is 22. So argon 18, 19, 20, 21, 22. Okay, so it will be 3d1 4s2, 4s2. So 18, 19, 20, 21, 3d2 4s2, 18, 19, 20, 21, 22. Okay, chromium, argon 18. So it will be 3d5 4s1. Okay, how much it will be? Just see. So chromium is in +3 state. +3 state means that time it will be, so 1 from here and 2 from here. So it will be 3d3 system. Okay. So, and here we'll see, so there is a presence of unpaired electrons here. So let us write for titanium also +2. +2, here it will be, no, +4, no, titanium is +4. So it will be 3d0 system. So this is also wrong. So chromium is the correct answer. Everybody got the same? Okay, Aishu has answered as D. Basavraj, no. Priyanka has answered it as D. Shivganka has also answered it as D. Very good. Okay, so understood. So whenever, remember, so the color complexes are due to why? They are shown by the system when you have unpaired electron. So if you have D0 or D10 system, okay, then that means what? That means they will be colorless. They will not impart any color. But other than this system, okay, whenever you have unpaired electron, then they are colored in nature. Okay, let us go for the next one. So the answer was what? It was D. Okay, I hope you have understood. So let us go for the next one. Okay, so 15th question. The common oxidation states of titanium are. So which are the common oxidation state of titanium? So titanium, it exhibits as what? Titanium 22. So argon 18. Okay, 3d2, 4s2. Fine. So what is the common oxidation shown by titanium? So these are the four options. Go through the options and tell me. Yes. So what is the minimum oxidation state? So yes, Aishu had answered it as D. Priyanka has also answered it as D. So the minimum oxidation state, it starts from what? So there are 4 electrons in its outermost shell. So the minimum electrons are 2, right? So the minimum oxidation state is in the of any metal is equal to what? The number of electrons in the 4s shell, right? So here the number of electrons in the minimum, they are how many? 2. And maximum is what? Maximum is equal to the sum of both. Okay, your 3d as well as the 4s electron. So the minimum is 2 and the maximum is +4. Okay, so the common oxidation states can be +2, +3 and +4. So it is option number D. Yes, Sita has also answered it as D. Okay, so the minimum is shown by the 4s electrons and the maximum is shown by the sum of both 3d and 4d. So the total number of electron, okay, common oxidation state shown by titanium is +2, +3 and +4. Okay, let us go for the next one. General electronic configuration of lanthanides is. So now we'll discuss some MCQs based on lanthanides. So what are the general electronic configuration of lanthanides? Okay. Aishu has answered it as A. So lanthanides are what? So these are also the transition metals, and they start from atomic number 58, that is cerium, to lutetium. Okay, to lutetium, which is 71. Okay, so the electronic configuration will be N minus 2 F 1 to 14, N minus 1. Okay, N minus 1 S2 P6 and D 0 to 1 NS2. So it is option number A. It is option number A. Okay. Let us go for the next one. Lanthanoids are. So what are lanthanoids? A, 14 elements in the sixth period. That is the atomic number 9203 that are filling 4F subshell. B, 14 elements in the seventh period with atomic number 9203 that are filling the 5F subshell. C, 14 elements in the sixth period, atomic number 58 to 71 that are filling 4F subshell. And D, 14 elements in the seventh period with the atomic number 58 to 71 that are filling the 4F subshell. Yes, which is the lanthanoid series. So just now I have told you in the previous. Oh, mhm. Yes, Triveni and Aishu has answered it correct. Okay, so it is what? It is again, I've got few more answers. Sita has also answered. Shushmita, your answer is not right. We are talking about lanthanides. Okay, so just now I told you about lanthanides. So lanthanides are the elements. They start from cerium. Cerium is 58 and to lutetium till 71, and they are the electrons are filled in what subshell? 4F subshell. Okay, they are filled in the 4F subshell. So option number C is the correct one. And they are in the sixth period. Okay, they are in the sixth period. Seventh period is your what? Actinoids. Okay, seventh period is your actinoids. So they are in the sixth period. Correct. Option number C is the correct answer. So these are present in the 4AF series. Okay, they start from cerium to lutetium. Okay, and these are placed in the sixth period. And in which group? In the third group. Okay, in the third group. Okay. Next one, which of the following oxidation states are the most characteristics for lead and tin respectively? So which are the following oxidation states, common oxidation states, which are characteristics for lead and tin? Lead is your Pb, tin is your Sn. So what is the common oxidation state? Aishu has answered it as A. Sita has also answered it as A. Okay. So the answer is A only. So all the group 4 elements, okay, so the group 4 elements, they will have tetravalency. Tetravalency means they will show +4 oxidation state. Okay, and here the what will happen? So as you go, okay, so lead can exhibit in both the state +2, and commonly it will exhibit it in +4 state, because the maximum electron present will be 4. So either 2 or +4. Similarly, tin also minimum is +2 and maximum is +4. Okay. So the stability of tetravalency decreases, okay, and that of the divalent increases. So because of that, Pb plus 2 is more stable than Pb plus 4, and here tin plus 4 is more stable than tin plus 2. So So this is something because of inert pair effect. Okay, inert pair effect. So option number A is the correct one. Let us go for the next one. Which one of the following ions have electronic configuration of this system? So your argon is 18. Argon is 18 and 3d6. Calculate 18 plus 6 electron. 24. So which system? D, cobalt plus 3. Okay, let us see. Okay, so the here what they have given, they have already given the ion in their oxidation states. Okay, so Mn is 25. So let us write for 25. So argon 18, then 3d5, 4s1. Okay, 18, 19. Then Fe is 26, argon 18. So if you write for nickel, it is 28. Okay. So it is 3d8, 4s2. So this is for nickel plus 3. So nickel plus 3 means it will be 3d7 system. Then if you write for Mn is 25. Okay. Then it will be argon. Okay, argon 3d 5, 6, 2, 20, 25. Okay. Then is your, so if it is Mn is how much? Plus 3. So if it is plus 3, it will be 3d4 system. Then next is your nickel or Fe. Fe is 26. Will be argon 3d6, 4s are 18 and 20, 26. Okay. So Fe plus 3 will be what system? 3d5 system. Then cobalt plus cobalt 27, argon 18, okay, and 3d7, 4s2. Then if this is cobalt is plus 3, then it will be 3d6 system. Okay. So the correct answer is D. Everybody is getting the same? Yes, Sita has answered as D. Triveni has answered it as D. So answer is D. Understood? So the answer is D. So like this. Is it clear? Yes. Shall we move for the next one? Okay. Which of the following pairs have the same size? So which of the following pair will have the same size? A, Fe plus 2 and nickel plus 2. B, zirconium plus 4 and titanium plus 4. C, zirconium plus 4 and HR plus 4. D, zinc plus 2 and HR plus 4. This is not HR, okay? It is HF. Do the correction. This is HF. This is HF. Okay, hafnium. There is no HF, HR. So it is hafnium. So which of the following will have the same size? Okay, Aishu has answered it as C. Again, one answer. Pavitra has also answered it as C. Yes, C is the correct answer. What is the reason? It is due to lanthanide contraction. It is due to lanthanide contraction. So due to lanthanide contraction, the size of hafnium and zirconium is nearly similar. Okay, it is nearly similar. So option number C is the correct answer. Next one. Which of the following is not correct about transition metals? Which of the following is not correct about transition metals? Their melting and boiling point are high. Their compounds are generally colored. They can form ionic or covalent compounds. They do not exhibit variable valency. Yes. Which is the incorrect statement among the following? They do not exhibit in. Yes. Aishu, Shiv Ganga, and Triveni answers are right. Option number D. They do not exhibit variable oxidation state. So they have the, yes, Sita, your answer is also correct. It is D. Okay. So they exhibit variable oxidation state. So they have that unique property. So these other properties are correct. Okay. They do not exhibit variable oxidation state or variable valency. It is a wrong statement. Okay. Let us go for the next one. The transition metals have a less tendency to form ions due to. So the transition metals, they have a less tendency to form ions due to A, high ionization energy, B, low heat of hydration of ions, C, high heat of sublimation, and D, all of the above. Okay, Priyanka has answered it as D. Pavitra, Aishu, all have answered it as D. Aishu, okay, one answer. Basavraj, Sita has also answered it as D. Yes, so answer number that is correct. So the transition metals, they have the less tendency to form ions due to, yes, they have high ionization enthalpy, low heat of hydration, high heat of sublimation. So the, yes, Shushmita, your answer is also correct. So option number D is the correct answer. Okay, let us go for the next one. Oxidation state of osmium in SO4 is. So what is the oxidation state of osmium? So X plus 4 into minus 2 equals to 0. X minus 8 equals to 0. So X is equals to plus 8. So the oxidation state of osmium is how much? It is plus 8. Yes, Priyanka, Aishu, Sita. Yes. Okay. Very good. So it is D. Yes, Pavitra, yes, it is D. Okay, so did you understand how to find the oxidation state? So like this, we are finding out the oxidation state. Okay, so oxidation state is found like this. So very important, it is asked. Okay, question is asked like this. Yes, Shiv Ganga, yes, correct. Answer is correct. Okay, let us go for the next one. The correct order of ionic radii of Y plus 3, La plus 3, EU plus 3, and Lu plus 3 is. So what is the correct order of ionic radii of these ions? Aishu has answered it as C. So you can see that. So we know that. Okay, Basavraj answered as D. Sita has answered it as C. Okay, let us see. So we know that, okay, in lanthanide series, there is a regular decrease in atomic as well as ionic radii. Why? Trivalent in nature. Okay, because of the trivalent in nature. Okay, because these are trivalent in nature. So you can see that there is a regular decrease in atomic as well as ionic radii of these trivalent ions. Okay, as the atomic number increases, as you know, so as the atomic number increases, there will be decrease in the size. The atomic radii, okay, and the ionic radii have some irregularities. So this irregularities, it decreases from lanthanum, that is 103 picometer, to lutetium, that is 86 picometer. Okay, so it is like this. So Y plus 3 is less than lutetium plus 3, Eu plus 3, and lanthanum plus 3. So the answer is this. Option number C. Yes, Shmita, your answer is correct. So it is option number C. Okay. Let us go for the next one. Glass mainly contains silver sulfide. B, gold is found in native state. C, zinc blend mainly contains zinc chloride. And D, copper pyrites also contains Fe2S3. Which of the following statement is incorrect? Yes. Zinc blend mainly contains zinc chloride, silver. So these are alloys. Okay, so these are alloys and their composition. So the answer is C. So zinc blend, okay, mainly contains zinc chloride. No. So zinc blend, it consists of ZnS. Okay, and not zinc chloride. So option number C. Yes, Aishu, your answer is correct. Okay, so these are the alloys, okay, of these ores. So zinc blend is what? It mainly consists of zinc sulfide and not zinc chloride. So option number C is the incorrect statement. Okay. Which of the following statement is not true about Morse salt? Which of the following statement is not true about Morse salt? A, it decolorizes KMnO4. B, it is a primary standard. C, it is a double salt. And D, oxidation state of iron is +3 in it. So which is not true about Morse salt? What is Morse salt? So please remember the formula of Morse salt. It is ferrous sulfate dot NH4 twice ammonium sulfate dot 6H2O. Okay, so this is what? This is your Morse salt. So what is the oxidation state of iron in this? So the oxidation state of iron is +2. Okay, it is +2. So what happens here? Here MnO4 minus, okay, plus 5Fe plus 2 plus 8H plus ion. So here the Mn, which is in +1 state, okay, it will be colored. Okay, it is colored. So when you react this more salt with the KMnO4, what will happen? It will become colorless. Okay, in the presence of acid, it becomes colorless, and this is the reaction. Okay, and second is what? So this, it decolorizes KMnO4. So Morse salt, so which is not true statement. So this correct statement is correct. Okay, so by seeing this reaction, you can see that KMnO4, okay, which is colored. Okay, when you react it with the more salt, it becomes it decolorizes, or it becomes colorless. So this first statement is correct, and it is used as a primary standard because it is available in pure state and it can be stored without decomposition. So second statement is also correct. Then third, yes, it is a double salt. In solution, okay, it will show the properties of Fe+2. It will show the properties of sulfate and ammonium plus. Okay, in the solution state, it will show the properties of this. So the option number D. Okay, what is the oxidation state of iron is +2. It is not +3. So option number D is not a true statement. Option number D. Okay, Aishu has answered. Shishmita has also answered it as D. Okay, good. So option number D is the correct answer. Is it clear? So please note down the things. Okay, fine. So let us go for the next one. Ammonium dichromate is used in some fireworks. Okay, ammonium dichromate it is used in some of the fireworks. The green colored powder blown in the air is, what is the green colored uh, powder blown in air? So ammonium dichromate, dichromate is Cr2O7. Okay, if you heat it, okay, what will happen? It will form Cr2O3 plus N2 plus 4H2O. So it is the green color. So when you, why it is, when it is used in fireworks, okay, it gives you a green color. The green color, it is due to what? It is due to this Cr2O3. Okay, so it is option number B. Yes, Aishu, your answer is correct. It is option number B. Okay, let us move for the next one. When ammonium dichromate is heated, the gas evolved is. So just now we saw. So which is the gas evolved when ammonium dichromate is heated? It is, yes, it is N, it is A. It is N2 gas. Correct answer. So A is the correct answer. So when ammonium dichromate is heated, so the gas evolved is a nitrogen gas. Okay. Then next question, cuprous compounds such as cuprous chloride, cuprous cyanide, and cuprous thiocyanates are the only salts stable in water due to, what is the reason why they are stable? High hydration energy of Cu plus ions, their inherent tendency not to disproportionate, diamagnetic in nature, and instability in water. Yes, what is the reason why cuprous chlorides compounds are soluble in, they are only stable in water? What is the reason? Yes. So we know that smaller the size of the ions, okay, smaller size of cations means they have more heat of hydration. Okay, they have more heat of hydration. Okay, so this hydration is what? It is a exothermic process. It is a exothermic process and heat is evolved in that. Okay, heat is evolved. Heat is evolved. Okay, and what will happen? Thus, the energy shown by the system will be lower in energy, and so it is A is the correct answer. Okay, so smaller the size of the cation, more is the heat of hydration. As it is exothermic in nature, heat is evolved. So option number A is the correct answer. Okay, let us go for the next one. Potassium dichromate on heating with aqueous NaOH gives you. So when you heat potassium dichromate K2Cr2O7, when you heat it with NaOH, okay, if you heat it with NaOH, what you will get? You will get K2Cr O4 plus Na2CrO4 plus H2O. Okay. So what is obtained? Your CrO4 2 minus is obtained. Okay, option number A. So these are the reactions from what? Your compounds, preparation of compounds. Okay. So in that dichromate system. So this is the reaction. Okay. So these are from the preparation part. Okay, next question. Which one of the following elements shows maximum number of different oxidation states in its compounds? Yes. Which one of the following elements shows maximum number of different oxidation state in its compounds? A, EU, B, lanthanum, C, germanium, and D, Amsterdam. So which of the elements will show maximum oxidation state? So EU, La, and this is GD, okay, and GD, okay, it shows +2, +3, +3, and +3 oxidation states, okay, respectively, while the actinoids AM, it will show +2, +3, +4, +5, and +6. Okay, so these are the common oxidation states shown by the lanthanoids, and these are the oxidation state shown by the actinoids. So actinoids, American, okay, American will show the more maximum oxidation states. Option number D. Yes, Aishu and Shivganga, yes. Okay, so we have seen that lanthanoids will show less variable oxidation states as compared to actinoids. Actinoids will show the maximum oxidation state. Which one of the following statement is not correct? Which of the following statement is not correct? A, B, C, and D. Read out. So atomic radius of zirconium, hafnium are same due to lanthanide contraction. This is correct. In lanthanide series, ionic radii of Ln plus 3 ions decreases. Correct. Then lanthanum is actually an element of transition series rather than lanthanoids. Correct. So option number A. Okay, option number A is incorrect statement. So option number A is the incorrect statement. Which one of the following ions is most stable in aqueous solution? So which one of the following ions is most stable in aqueous solution? Yes, palladium plus 3, titanium plus 3, Mn plus 3, or chromium plus 3. Yes, which way is more stable? So it is chromium plus 3. Okay, chromium plus 3 is in its most oxidation state. Yes, option number D. So out of these complexes, which is the colorless species? So you have to see, okay, find the oxidation state of each system and see which is D0 and D10. So only when it is D0 and D10, it is colorless. Okay, and if you have unpaired out the oxidation state of each, okay, Fe6. So find the oxidation state of each and see. What is the answer? So Ti F6 minus 2. Titanium, oxidation state of titanium is what? X plus 6 into minus 1 equals to minus 2. X minus 6 is equals to minus 2. X minus 2 plus 6 equals to 4. So the oxidation state of titanium in this complex is plus 4. So plus 4 means titanium is, when you have titanium is 22, it is argon 18, 3d2 and 4s2. So it is 3d0. Okay. So it is a colorless system. Now next is what? CO F6 3 minus. So find the oxidation state. X minus 6 is equals to minus 3. X minus 3 plus 6 is equals to 3. X is plus 3. So X cobalt is 27, 3d7 and 4s2. When cobalt is in plus 3 system, so it is 3d6 system. Right. So 3d6 system, what is the 1, 2, 3, 4? So 1, 2, 3, 4, 5, and 6. So you have unpaired electron. So this is colored. Okay, this is a colored system. Your COF6, colored. Next is Cu2Cl2. So 2x plus 2 minus 1 equals to 0. So 2x minus 2 equals to 0. 2x equals to 2. X is equals to plus 1. Okay. So plus 1, copper when it is in plus 1. So argon 3d10 system. So this is whenever you have 3d10 system. So that time this is also colored, colorless, right? So this is also colorless and this is also colorless. So means which complex? Just see titanium, and this is option number B. Option number B. Everybody got the same? Yes, Aishu has answered it as B. What about others? Others slept? Yes, no responses. Please give the answers. So option number B. Okay, so whenever you have D0 system or D10 system, so they will be colorless. So this particular complex is colorless in nature. Okay, Triveni has also answered it as B. Understood? Is it clear? Okay, so let us go for the next one. Which of the following ions will exhibit color in aqueous solutions? So La plus 3. Okay, La plus 3. So this is, so what happens? Okay, it will be 54. So if you lose the 3 electrons, so it will be 54. So it will be the oxidation state of xenon. Then titanium plus 3. Titanium plus 3 is 24. So plus 3 state means it is argon 18 and 3D 1. 3D 1 system. Okay, so this will exhibit color. Okay, then lutetium plus 3. So lutetium plus 3, the electrons after losing plus 3 will be 68. So it is xenon 4f14. Okay, then scandium plus 3. Scandium is scandium. Okay, is 21. So after losing, so it is argon 18, 3D 18, 19, 20, 21. So scandium plus 3 will be 3D0. So this is also colorless. This is also colorless. This is also colorless. This is colored. So option number B. Are you getting the same? Yes. Triveni has answered as B. What about others? Yes. Are you getting the same? Okay. Is it clear? Are the questions clear? So let's take this one. Which is not amphoteric in nature? Which is not amphoteric in nature? Last question. So option number C. Okay, answer is which is not amphoteric is Fe plus 3. So oxides of metals in their low oxidation states are generally basic in nature, whereas the oxides of metals in their higher oxidation states are acidic in nature. And whenever the oxidation state is in intermediate state, okay, then they are amphoteric in nature. So your Fe plus 3 is not amphoteric, okay, as it is in highest oxidation state. Okay, the maximum oxidation state shown by Fe is plus 3. So it is not amphoteric in nature. So option number C is the correct answer. Okay, is it clear? Okay, so are these questions clear? So whatever the questions, so we have, I've tried to cover maximum things. Okay, so I've tried to cover maximum things from this DNF block chapter. Okay, so these are some of the type of questions can be asked for your exam. So please solve similar questions, okay, from the different books, so that it will be a good practice for you. So go through the synopsis, go through the other questions, okay, from and try to uh, answer them. Okay, I hope. Fine. So after this, you'll be having the test. So please take up the test, okay, so that you will understand how much you have understood the things. Okay, fine. So thank you. Okay, so tomorrow we are going to take the next topic. So that is coordination compounds. So we'll meet you in the next class. Thank you.